Hello everyone. In this video we are going to discuss some problems on fiber optics. So our first problem is compute the numerical aperture and the acceptance angle of an optical fiber having refractive indices 1.54 for core and 1.50 for cladding, and the launching medium is air. So let us first draw the schematic diagram of the fiber. So we have drawn here a core and a cladding. N1 is the refractive index of the core and N2 is the refractive index of the cladding, and air is the launching medium. So let us first see the given parameters. So the given parameters are refractive index of the core, which we have taken as N1, is 1.54. Refractive index of the cladding N2, and it is given as 1.50. Refractive index of the launching medium. Here in this case, the launching medium is air. So let us take this refractive index as n. So n is equal to 1. Now the numerical aperture which we need to find out, Na, is sine theta a, which is root over of n1 square minus n2 square divided by n. N1 square is 1.54 square and N2 is 1.50 square divided by 1. So the answer is 0.3487, which is equal to 0.35. Now we need to find the acceptance angle theta. So theta acceptance angle, that is theta A, is basically sine inverse root over of n1 square minus of n2 square divided by n. So let us put this value. It is 0.35. So sine inverse 0.35, which is equal to 20.48. So the acceptance angle is 20.48. Now let us move to our next problem. Our next problem is, in an optical fiber, the core material has refractive index 1.42 and the refractive index of the cladding is 1.4. Find the propagation angle. So let us first see what is the propagation angle. So we are drawing the schematic diagram. I have drawn here the core. Now I am drawing the cladding. So this is the axis of the fiber. A ray is incident at the fiber face, and now this ray is incident at an angle phi c. So phi c here is the critical angle, so that at the core cladding interface the ray grazes the boundary between the core and the cladding, and this is theta c. So basically theta c is the angle the ray is making with the axis. So this theta c is the propagation angle. So the given parameters of the problem are: the refractive index n1 of the core is 1.42, the refractive index of the cladding n2 is 1.4, now I have drawn here the point ABC, which makes a triangle. Now at the point B, by Snell's law, between the core and the cladding, where core has the refractive index n1 and n2 is the refractive index of the cladding. If we apply Snell's law, we get n1 sine phi c will be equal to n2 sine 90 degree. So sine phi c is n2 by n1. Now from the triangle ABC, you can see the triangle in the schematic diagram, that from this triangle ABC we get sine phi c is equal to AC by AB, which is equal to n2 by n1. Again, if you see the triangle carefully, theta c is the angle. So if we take cos theta c, which is also equal to AC by AB, that is equal to n2 by n1. n2 in our problem is 1.40 and n1 is 1.42. So n2 by n1 we get 0.9859, which is equal to 0.986. Therefore, the propagation angle theta c is equal to cos inverse 0.986. So the propagation angle theta c is 9.6 degree. Now let us move to our next problem. In an optical fiber, the refractive index of the core is 1.5 and the refractive index of the cladding is 1.2. What is the value of the critical angle? Calculate the value of the angle of acceptance cone. Now the given parameters, the refractive index of the core is 1.5 and the refractive index of the cladding is 1.2. The critical angle, as you know, it is sine phi c, which is equal to n2 by n1, as we have seen in our previous problem. So that is equal to 1.2 by 1.5, which is equal to 0.8. Therefore, phi c is equal to sine inverse 0.8, that is 53.1 degree. Now we know that sine theta a is equal to n1 square minus n2 square. So therefore, theta a is the acceptance angle. Theta a is equal to sine inverse n1 square minus n2 square. So if we calculate it, putting the value of n1 and n2, that is sine inverse 0.9, so we get it as 64.15. Now we move on to the last part of our problem, that is to find the value of the angle of acceptance cone. So let us draw the schematic diagram. I have drawn here the core and the cladding, and this is the acceptance cone. So this acceptance angle is theta a. So if a ray enters this acceptance cone, it will undergo total internal reflection and it will be guided through the fiber. Therefore, the angle of acceptance cone is given by twice of theta a, that is the acceptance angle. So it is equal to 128 degree. So 128 degree is the value of the angle of acceptance cone.